Alright, so for our physics midterm, Arvin and I decided to use like the physics in Rocket League, because Rocket League is heavily based on physics, in order to calculate the force applied in order to demolish a car within Rocket League and how an actual car works in real life and both Rocket League. So we just found a match. Do we just get scored on? After much analysis of the footage before, I can confirm that my team scored and the enemy team did not score. Alright, this should be pretty easy. I mean, all we have to do is make up 2 points in 1 minute. I mean, I don't see how it's gonna... Oh, shoot. I don't see how bad that can be. Wait, hold up. A bot did better than me? Alright, this man is taking too long. I'm gonna leave if he doesn't ready up pretty soon. Alright, that's it. I'm done. Alright, match 2. We should be good. I mean, hopefully it doesn't go as poorly as last time, so... Too easy, man, too easy. I should go professional in this game, man. Alright, so now it's time for the boring math part of how a car actually works. And, like, kind of the energy states of what's going on within the entire process. So for those of you who do not know, a car is made, well, actually, a car engine is made out of multiple cylinders. So here is a cylinder. And inside each of these cylinders is like 3 main things. Like you have the input, which is mainly fuel and air. You have the main action where there's like a piston that like moves up and down, which causes the main combustion reaction. Then you have your output pipe, which is just what's left over. So input is air and gas, and then the output is like smoky vape, you know. Right, so there are multiple steps to the process of converting this air and gas mixture into energy, smoke vape. So here, I'll try to draw the cylinder right here. So as you can see, there's like a track at the bottom, which is going to be connected to the piston head. The wall that I'm drawing right now is like to block the input and output pipes. Oh. So here's the piston. So as you can see, like the piston is connected to a like wheel crank thing that like turns around, spins, so like there it goes up. So this is like the default skin for the cylinders. So this is like what it starts out looking like. Then next skin will be when the chamber has the petrol and air inside. So give me a moment. Alright, so this is the gassy skin, basically the skin where the gas is inside the chamber and is prepped to be future Dorian here with some knowledge for you mortals. The energy from where this entire system comes from is from the gas lane, which has energy within its chemical bonds. So, just a disclaimer. Alright, so in this next phase, what's going to be happening is the piston is going to move up because the wheel at the bottom is going to rotate. So, yeah, I forgot to draw a head there. So what this leads to is an increase in pressure within the chamber, which allows for better energy conversion and fuel efficiency overall. So this is the pressured skin. So the next skin is going to be called the triggered skin. It's basically what actually happens when a spark plug ignites this pressurized gas within the chamber. What results is an explosion that has an immense amount of heat and energy capabilities. So I think we learned this in chemistry, but like temperature and once its phase is related. Temperature and pressure are related, so what's going to happen is the next phase is that the pressure is going to cause the piston to move down. So you can see throughout this entire process that the circle at the bottom keeps on rotating, which causes the piston to continue moving up and down, basically keeping the cycle continuing forever and ever until you turn off the car. So this circle thing is constantly rotating. Not only the piston, but also a belt that loops around it. So this belt is connected to the car's axle. So when it's in this form, it has kinetic rotational energy. So yeah, this is the tire setup. Has some pretty thick wheels. Alright, so the axle is connected to the belt that is connected to the cylinders, so that way the cylinder's energy can be transferred into the axle. So as the axle spins and spins, since it's connected to the wheels, it causes the wheels to spin and spin. So the friction, so whenever the wheels are on the ground, right, the friction is slowing down the car's wheels, but because of Newton's, I don't know which law, but one of Newton's laws that states every action has an equal and opposite reaction, the force of friction, which is pulling the car backwards, is pushing the car forwards. So this transfers the rotational energy into kinetic energy. So there's also more friction between the belt and the axle, which is pretty complex, but what's even more complex is the friction between the ball bearings and the axle. I spent probably 3 hours trying to figure it out, and I just couldn't, so unfortunately we are not going to be finding the force of friction acting on the car in Rocket League. Hey, could you remember? This video is actually about Rocket League. Alright. So now that we have finished part one of the boring aspects of physics and math and whatnot, let's spend a few, I don't know, 1 minute about just watching my diamond gameplay of Rocket League and appreciate my skill. So, yep. Alright, so the other reason for me showing this clip is what you just saw, which was a demolition. So that's what Arvin is going to be discussing in his part of the math. So brace yourself, there's more math coming. Sorry, guys.
How much force does it take to destroy the buggy in Rocket League? We decided to use these formulas to address this question in no particular order. We started out by drawing out the field at which the video game is played. It's about 90 meters by 120 meters, according to outside sources. And according to those sources, the buggies or cars that are being used in the game are around 1,000 kilograms. So the speed at which it takes for this buggy to go fast enough to crash into the other car that is staying still and actually break it is the super speed, and for the time it takes for that.
Alright, so Arvin may have forgotten to send half of his math, so I'm just gonna jump in real fast and try to connect what he did. So what I believe he chose to do was he first took the 120 meters it takes in order to cross the field and divided it by 4.5 seconds in order to get the average velocity. We also measured that in order to reach super speed, it also takes 4.5 seconds. So that gives us an acceleration of 5.97 meters per second squared. So I believe that this is where Arvin left off. So, yeah. Oh yeah, happy birthday to Arvin, which, yeah, it's his birthday as of the day that I'm editing this.
We decided to do
So hopefully you guys learned something or actually enjoyed the video, unlike me. So thank you guys all for watching.